Morning, everyone. Up here on my screen here, I have the solutions to homework number 52. Looks like you guys are doing a really great job with this, so I appreciate you, watching the lesson and then getting your work done instead of our usual. I just have to do it this way for now. All right, so for homework 52, you are drawing the angle measurements that are given. And remember, we talked about how the initial side, okay, you have your initial side, which is always starting here on the right-hand side of your x-axis, okay, and it goes 90, 180, 270, 360. So your terminal side, okay, is where it ends. This is how I want you to draw your graphs. This is perfect. So you have your terminal side of where it ends. It's a little past 90 degrees, for example. And then you just have an arrow from the initial side to your terminal side just to show me which way it's going, okay? So that would be great. For that one, number 7 is negative 900 degrees. All right, so you are starting at your initial side and you are going you're going clockwise here. 360, another 360, okay, and you're showing that with your little angle measurement here, okay, your little curly Q, right? And then it ends up at negative 900, which is at the 180 degrees mark, okay, and writing that. 450 degrees is 360 plus 90, so we add that on there. And negative 10 degrees would be just a little bit clockwise here from 0, okay, and labeling that. 9 through 12, you were given an angle measurement, and you're asked to give that angle measurement in another positive coterminal and a negative coterminal. So remember, when you're finding coterminal, that just means it lands at the same spot on your graph, okay? So the way that we do that is take the angle measurement given and add 360 degrees to get to a positive until you get to a positive, or you could subtract 360 degrees to get to a negative. Okay, so positives and negatives there. 13 through 18 were ones where you had to convert from degrees to radians or radians to degrees. So if you start with a degree, the conversion factor is to multiply that by pi radians over 180 degrees. Okay, and then simplify accordingly. The degrees cancel. All right, and we're going to keep the pi with that problem as well, okay? You're going from radians to degrees. Radians typically have a pi in them. All right, so we're going to multiply that by 180 degrees over pi. And what happens is your pi's usually cancel. All right, and then we have our answer in degrees. Okay? So I want to teach the last part of, let me show you number 21 and 22. These were determining what the mistake was. All right, so for number 21, you could have something like what they have written here. Okay, and then same thing with number 22. Just wanted to get you thinking about these. If you didn't do so great with those two, don't worry too much. The main parts are being able to graph, okay, giving a positive and a negative coterminal, and then going from degrees to radians or radians to degrees, okay? So this is the last actual lesson that I would like to go over with you. Tomorrow, Wednesday, we will do a review of these two pieces, and then Thursday we'll have our quick quiz, and that will be it, okay? So if you are taking pre-calc, this is something called a unit circle. Some Algebra 2 teachers, and I actually have in the past, have had my kids memorize this, and you're probably like, oh, geez. So there's degrees and radians in here, and then it actually gives you the points of the circle, which kind of have different meanings in terms of triangles that are in here, okay? So the main thing that you just need to remember is that 180 degrees is pi, right? That's what we're using to convert. And all the way around, which is 360 degrees, is 2 pi, okay? So these two formulas are what I need you to write down today, all right? We're going to be using these two formulas to find some crucial pieces on a circle, okay? So it might be a good idea to first draw this little circle here, draw this diagram, all right? When we have a circle, you have your center of your circle, all right? That's called your central angle. So we're going to be talking about little pieces of this circle. Okay, this piece, when you have a piece of a circle, that's called a sector. So think about like a pizza slice. That is a sector of the whole pie. Okay. Now, the central angle, excuse me, angle here is theta, and we're used to seeing that in degree mode. Okay, so we're going to be finding the area of that whole thing. So in this case, the blue piece area. And we're also going to be finding the length of this arc, which is called S. All right, so it's kind of like if I were to take a tape measure and measure from here to here, what that would be. So the way that I find that arc length, which is from here to here, okay, is we're going to make sure you write these down. The formula for it is the radius. Remember, radius is the distance from the middle to the side times theta times your central angle. But one of the biggest things about using this formula that's pretty easy is that theta has to be in radians. It has to be in radians, okay, if you want to use that. All right, so we know now how to convert things that are in degrees to radians. All right, same thing with the area formula. If I wanted to find the area of this sector, which is all the filled in piece there, I'm going to do 1/2 times the radius squared times theta. Again, that theta has to be in radians. Okay? All right. So the first kind, there's a few different kinds of problems that we're going to do today. All right. So I'm going to post the blank notes of these up so that you have them if you want to, print them out. All right. So the area of each shaded region, okay, remember the formulas that we're going to be using here, let's write them up top. The length of the arc is the radius times theta. And the area of the arc is 1/2 the radius squared times theta. Okay, so for these three problems, here's what's given. We are given a piece of the arc here, okay? They give us the radius here, and they give us what the length of the arc is, okay? So the first thing we're going to do is, in order to use and figure out what the area formula is, take a look. You have your radius, but oh geez, I need theta. Well, they give us information to find theta. Okay, so here's what we're going to do. We're going to use this length of the arc formula to find theta. Okay, and that's what you're going to be doing for each of these. So the length of the arc, the formula we use is S equals R times theta. Okay, give us what the length of the arc is, which is S. So we have 38.38. That's the length of the arc, S. They give us the radius, which is 11, and now I need to find theta. So what would I do to each side to find theta? I would divide by 11, right? You're solving for theta. Okay, so I have 38.38 divided by 11. For each of these problems, I would like you to round to 2 decimal places. So here's where it gets a little funny. 3.49, huh? Is that 3.49 degrees? No, okay? That's in radians. And you're probably like, wait, didn't Miss Devine say that radians have pi in them? Yes, they do, okay? But when we're using a formula to find something in another formula, okay, radians can be written as a decimal. Now that I found that radians, I can find my area. Okay, watch. It's just plugging in 1/2 times my radius, which was 11, squared times theta. Okay, please just be sure that you use your order of operations here. So my calculator, I'm going to do my 11 squared, enter. And then I can just multiply by 0.5, which is that 1/2, times 3.49. And I'm going to round my decimal, okay, to 2 decimal places. So I get 211.15. I'm going to put that over here. Now everything was being measured in inches. The length of this arc, okay, was, they gave me 38.38 inches. Think of a tape measure, okay? Area, though, is units squared. So just be sure when you're writing your area that you take the units and you put squared there, okay? All right, so let's try another one that's similar to that. Okay, I'm going to do this second one just because they give me a degree instead of a radius, but you're doing the same thing. All right, so I'm going to use the formula for length of the arc to find what I need to for the area. But first, when I have this degree measurement of 150 degrees, in order to use either of those formulas, it has to be in radians. So if you see a degree measurement that's in degrees, all right, we need to change that to radians first. Okay, so remember, you're going to take 150 degrees, okay, times pi over 180. All right, so we're going to multiply straight across here. Because we're using this formula, we're actually going to use the decimal of this. Okay, so we're going to do 150 pi. Use the pi button on your calculator, which is on the left-hand side of your calculator, divided by 180. Okay, so that means that my degree measurement of 150 degrees in radians is 2.62 radians, okay? 2.62 radians. So now what I'm going to do is exactly what I did for the first problem now. I'm going to use this S, which is the length of the arc, 18.32, equals the radius, oh geez, I don't know that, times theta. And I made my theta in radians so I can use this. Okay, use this formula. Divide each side by 2.62 radians. Okay, so I have 18.32 divided by 2.62. I'm going to round that. I get 6.99. Okay, so my radius is 6.99 what? Well, we were in terms of meters. Okay. And now, since I have all the pieces, I have my radius, I have my theta, I will have no problem finding that area now. Okay, so it's just a process. 1/2 times the radius squared, times theta, 2.62. So here's how we type it in. Do your squaring first. 6.99 to the second power. Enter. Okay. Times by 0.5, which is that 1/2 there, times by 2.62, which was theta. You're rounding to 2 decimal places. Now remember, area has to be units squared. Okay. So this one that's starred here is the same process as the first one. So I'm going to put the area there so that if you want to try that one on your own and then check your answer, it's there. So if you need to pause here, you can do that. Okay, let's try a few other ones. Okay, I'm not going to do all three of these because they're very similar to the ones that we just did. Okay, but for each of these, notice what's given. They are giving you the length of the arc, S, and they're asking for the area. Okay, so let's do one more together, and then I'm going to give you the answers for the other ones if you'd like to check them. All right, I'm going to do this first one. Okay, here we go. So length of the arc, S, got it. All right. So that means if I measured from here to here, it's 200.81 meters. Okay, remember your two formulas, radius times theta. And then for your area, it's 1/2 the radius squared times theta. All right. I'm noticing that my theta in here is in degrees. It's given to me, but it's in degrees. So the first thing I'm going to do is convert it to radians. So 90 times pi over 180. That's my conversion factor, remember. Okay, I'm going to multiply straight across. I get 90 pi over 180. So if this was a conversion problem, you would simplify this, right? And you would just make it 1/2 pi or pi over 2. Okay, but when you're going to use these formulas, it's easier for us to use the decimal of the radians. Okay, so you can type in 90 pi divided by 180, or you can just type in. Okay, so the arc length given, I had to change it. It was incorrect. So it's 25.12 meters, okay, equals my radius, I don't know you, times 1.57 as my theta. Divide each side by 1.57. That's going to give me my radius, okay, which is 25.12 divided by 1.57. It's exactly 16 as your radius, okay? Use that to do your area now. You have all of your information. 16 squared, okay, 1/2, and then your theta was 1.57, okay? So now we got 16 squared times 0.5 times 16 squared times 0.5 times 1.57. Okay, and we should be getting 200.96. And just remember, length of the arc is always a unit, whether it be meters or centimeters. The area is just that unit squared. Okay, here are the solutions to the other two problems. If you want to check those at some point. Okay, these are the areas for those. Move that out of the way. And this one out of the way. All right, so these are the last kinds of problems, and it's sad to say that I'll ever teach you. And it's exactly what we just did. All I'm asking you to do, though, is to fill in the missing pieces. All right, so you'll do all of your work and then plug in what each of these are. The only thing you need to make note of here is that for your central angle, which is theta, for all of these, okay, when you list it in there, please make sure that you are putting it in degree mode, okay, in a degree, okay? So you need the radian one, to use the problem, to do the problem out, all right? But you need to also put the degree in degree form there too. So let's look at this first one. What's given? Okay. They give us the radius, so that's 15 inches. So I'll throw that in there. Okay, they give me my central angle, which is 210 degrees. Okay, and I need to find the length of the arc. So S. Okay, so the only thing I need to do here is if my formula is S equals R times theta, there's no mention of area here. All I need to do, I know my radius, I know my theta. but I do need to put that theta into radian mode in order to plug it in. Okay, no problem. 210 times pi over 180. So it's 210 pi over 180. And since we're just going to use the decimal form of it, I'm just not even going to simplify it. I'm just going to type that into my calculator. 210 times pi divided by 180. That's going to give me that my theta in radians is 3.67 radians. Well, that's all I really need to use now to find my length of the arc. Okay, so I have S equals, I have my radius, okay, which is 15, and then I have my degree measurement in radians. Okay, so just multiply 15 times 3.67. Now remember, when you're doing length of the arc, you need units here. It's inches because that's what was given in my problem for the radius. Okay, so for each of these, you're doing exactly the same thing. The only thing that's different is you may be missing something, okay? And then you just have to figure out what that piece is. So for this one, you are given theta, you're giving theta, right? 50 degrees. You're given the arc length, which is 9.6. You need to find the radius. Okay, so you're going to convert this angle measurement into radians first, and it's going to go right here. Okay, you know the length of the arc, and you're solving for the radius. All right, this one, you know your S. Okay, you know that this is 15.87 meters. You know the radius is 7 meters. What's the central angle? So let's look at this one. 15.87 equals my radius times theta, so 7 times theta. Divide each side by 7. I get 2.27 as my theta. What I'm asking you, though, is if you could please just put that in degree form as well. Okay, so we're going to do 2.27, and we're going to multiply that by 180 over pi. Okay, so I'm going to do 2.27 times, and then in parentheses, I'm going to do 180 divided by pi. All right, and I get that it's 130.06 degrees. All right, the radius for this one you should be getting 11 centimeters for that one. Oop. Okay, let me move this. All right, when you solve for that one. Okay, the only other kinds of problems that you'll see is instead of finding the length or using the length formula, okay, you're using the area formula. So for each of these, notice they're just area. So we're going to fill in what we know and find what we're missing. Okay, so you'll always have kind of, you'll have your 3 pieces, and then you have to figure out what is missing. All right, so let's take a look here. For this first one, we know that the area they give it to us is 602.88 inches squared. They also tell us our central angle is 270 degrees. What I need to find is the radius. You're using this formula. Okay, the only problem is if theta is given to you in degrees, you've got to change that to radians first. Okay, so you multiply straight across. simplify if you want to, or since we're going to just be using the decimal for it, I'm going to type it in my calculator, 270 pi divided by 180. Okay, so that means in radians, that degree measurement is 4.71 radians. Guess what? I have all my information to find my radius now. Okay, here we go. Area equals 1/2 times the radius squared times my theta, which is 4.71. Okay, my area, forgot, they gave it to me. So that's 602.88. Okay, so to solve this, do 1/2 times 4.71. That's 2.36. R squared equals 602.88. How do I solve? Divide each side by 2.36. You're solving for the missing part, which should be something that you're very familiar with in algebra. Okay? I round that. I get 255.46 equals R squared. How do I solve for R? Do the square root of each side. Okay, so all you're doing to solve for R, okay, is doing the square root. Use your square root button on your calculator. 255.46. My radius is 15.98. 15.98. What was my unit? Inches. Okay, for this second one, I'll show you the things that you are given. You're given your area. You're given your radius. You need to find your central angle, theta. Okay, so you're going to plug in your radius and your area. Your theta that you get is going to be in radians, and then you're going to convert that over to degrees. Okay, and the degree measurement that you should get is 139.8 degrees. Okay, and then the last one up here, you're given your central angle. You are given your radius. This one's the easiest one of the three. You're given your radius, and you just need to find your area. Okay, the only thing that you need to do first is convert that angle measurement into radians. Multiply it by pi over 180, and then you plug in your radius and your theta. Okay, oh, this has to have a square in there. I forgot to put that in there. Okay. So on Google Classroom, you are going to see a worksheet that has every little piece that I just went over, just different numbers. Okay, so let's just look back quickly. These are your two formulas. You just need to know how to use them. All right, the crucial part is you have to be able to use theta, okay? The theta that you plug into either of these has to be in radians, and that's what you did for homework last night. Okay. So tomorrow we will review the ARC worksheet. I'll see what questions you have. We'll spend the whole day, the whole class period reviewing. Okay, we'll try problems out. Please make sure for the ARC worksheet that you do all of your work on a separate sheet of paper. I don't expect you to redraw each of the diagrams. You could put your answers, just on your separate sheet of paper. All right, but I need to see work. You can't just have solutions there. This is the work that's required. Okay, 2 decimal places is what we're sticking with. This homework will be due Wednesday morning before class. Any questions, please email me. Okay, thank you.